Hi everyone, my name is Jie Zhao, and today I'm gonna share my project about using stock data to predict price trends. And this project is mainly about to use machine learning technology to do some data prediction in the future. And okay, for the problem definition part, this project objective is to use stock data to predict price trends, aiding investors in making informed decisions. And the role of data mining is uncover patterns in stock prices and financial metrics to forecast market movements. And utilizing machine learning models, and this data can be harnessed to forecast prices, offering investors a foundation for developing data-driven investment strategies. And the data source is from Kaggle, and here is the address for the data source. Okay, and first part is data understanding. I mainly use one big data set is Amazon Inc. historical stored data. And in the whole project, I separate this big data set into two different data sets, one for training and one for testing. Okay, and for data features, the whole data set including six columns, date, open price, high price, low price, close price, and volume. Um, for me, this project's analysis approach is mainly use time series analysis to understand market dynamics and uncover patterns for future price prediction. Okay, and I mainly use four different model in this project, and first two in R language and last two in Python. So firstly, I'm gonna do some data preparation for R. The first step is handling missing values. This part is to remove rows with any missing value. And the second part is handling outliers. And this part is to use statistical measures in R language to handle the outliers. And I mainly use the z-scores function. And the third part is integration and segmentation. I split the whole dataset into two parts, one for training and one for testing. Okay, and here is the code handling missing values in the R language, and I use the omit data to address missing values and to enhance data quality. And you can see after the data cleaning, there are 57, 58 data in the whole data set. And and then here is a code for handling outliers. I use these scores, and this scores is from uh, a, pa a package in our language, and this is really good for the really good to handle outliers. And then for integration and segmentations, I use carrot package to split 80% data for training and 20% for testing. And you know, the carrot package include the create data partition function for this package is really useful for creating balanced split of data. Okay, and I mainly use the distribution of close price column value to do the prediction because I think people may pay more attention on the close price for the stock value. Okay, and here is the code. You can see 80% data for training and 20% data for testing. And now I got two data sets. One is training data and another is test data. And now I'm gonna introduce my modeling. And the first model is ARIMA model in R. ARIMA model is autoregressive integrated moving average model. It's a very popular time series forecasting method, and it can be used the at the forecast package in R for ARIMA modeling. And here's the code. You can see I just use the package to start the whole model, and after that I got my predictions, prediction measures. You can see the mean error. The mean error is very close to zero, and so we can suppose this is a good performance. And for mean percentage error, this model has a very low MPE, mean percentage error. So it should have a good predictive accuracy. And for the mean absolute scaled error, this is a relative measure of the error. The MASE is much lower than 1, which indicates good predictive performance. So generally say the ARIMA model is kind of good for the stock prediction. Okay, and the second model is expressional smoothing in R. Expressional smoothing is another method for making short-term forecast. And here is the code. You can see I set frequency equal to 252 because for the whole year, the stock market only opened for 252 days, not 365 days. So I set frequency at these parameters. And you can see the mean for this model, the mean error is close to zero, but not as good as the ARIMA model. And for the MPE, the MPE is low, but not too low. So, and it is good, but not as good as the ARIMA model. And for the MASE, also MASE is good, but not good as good as the ARIMA model. So you can see for this two model in R, ARIMA model is for this whole data set performed better, and I think ARIMA model may more fit for this kind of problems. And then I will introduce two other functions in Python. And here we should do the data preparation for Python because you know the data preparation is different from the same things in R. So you can see I reload the data and I drop non-numerical columns like this. And I define the target variable and features. Split the data into training and testing sets, also 80% and 20%. And finally standardize the features. Okay, and the first model I use is linear regression. Linear regression is a statistical method that models the relationship between a dependent variable and one or more independent variables by fitting a linear equation to observed data. And here is how I implement this model, and I calculate the ME, MP, and MASE using using different functions, and you can see the main arrow is larger than 1. This is not that good. Actually, this is not a good performance. And for MPE, MPE is not so low. It's greater than absolute 1, so not good also. And MASE is much larger than the two models in R. So linear regression, I think, is not a good model for the stock prediction. Okay, the last model I use is random forest. Random forest is an ensemble learning method that operates by constructing multiple decision trees at training time and outputting the main prediction of the individual trees. And you can see the code I try to implement the random forest model. And I also calculate the ME, MP, and MASE. And you can see these three measures is really good. And I think this is the random forest is the best is the best fitting for this whole data set. So this is for model I use for this project, and I think the random forest performed the best, and the linear regression maybe not good, and maybe at the least. So while linear regression offers simplicity and interpretability, its assumption of linearity might be a limiting factor. Random forest, on the other hand, is more robust in handling complex, nonlinear relationships, but at the cost of interpretability and com computational intensity. The choice between them would depend on the specific characteristics of my dataset and my project goals. So for my project goals, in the future I prefer to choose random forest or ARIMA model to do the stock price prediction, and I will try in the future to compare which is better for these two models. So this is my project, and that's it. Thank you.